There we go. Okay, so today we have systems of linear equations and matrices. So a system of linear equations represents two lines on a graph. And if they intersect, they are said to have a solution. So let me show you what I'm talking about so it doesn't sound crazy. So if we have a graph and we are given two lines, two linear functions, let's say I have this graph and the other one, let's say I have it going this way. Well, right now we have two linear equations, and if these linear equations intersect, their solution is unique because the point where they intersect is a solution to both equations. And if two lines intersect, we say that the system is consistent, meaning the system has a unique solution. If our lines do not intersect, let's show what that looks like. Oops. If our lines do not intersect, get another graph, and let's say I have a graph that looks like this, and I have a line that looks like that. If the two lines do not intersect, then this system is said to have no solution. So this would be an inconsistent system, meaning there is no solution. Okay, awesome. All right, so those are two situations we'll run into. We might run into a third, but I'll let you know if we do. Okay, so right now we just want to look for the unique solution to both equations. We want to find that point x, y. And problem A, it says, is the point 7, 2 a solution to this following system? So remember, every point is labeled as x and y. So in order to check if we have a solution, we just take 7, plug it in for x, take 2, plug it in for y, and see if it holds true for both equations. Oh, that's ugly. There we go. So x, y, there we go. So let's go ahead and plug it into the first equation and see if it's true. So I'm going to say 7, 2, and then into the first equation, x minus y equals 5. Plug in 7 for x, plug in 2 for y, and is 7 minus 2 equal to 5?
Yes.
Yeah, so that's good. That checks out so far, but this has to work for both equations. So now let's try the other. 7, 2 into 2x plus y equal to 1. And again, plug in 7 for x. So you'd have 2 times 7 plus y, which is 2, equal to 1. And you would get 14 plus 2 equal to 1. Does 14 plus 2 equal 1?
No.
No.
No, right? Not at all. So this says that 16 is equal to 1, which is not true. So this point 7, 2 is not a solution to both systems. All right. Let's see, 7, 2, 2x plus y equal to 1. Yeah, 14 plus 2. Okay. Cool. And if I did that, y equals. Okay, cool. All right, so now we are going to be given systems of equations and we will be solving for that solution. So one of the easiest methods to solve a system of equations is by using something called elimination method. And elimination method puts all the power of mathematics into the student's hands. So you are given the option of what to do here. And the biggest option is, what variable do you want to eliminate? So let's look at number one. You have 2x minus y equal to 0 and 3x plus 5y equal to 39. And there's no wrong answer here. You choose a variable you guys want to get rid of. So would you like to get rid of x or would you like to get rid of y?
X.
Let's get rid of x. Okay. So I'm going to show you how elimination method works. So we want to get rid of x. So whenever you solve a system of equations, you add the equations together. But when you add them, a variable has to eliminate. Okay. So if you want to get rid of your x's, you need to find a common multiple that is between 2 and 3. So what is the least common multiple that 2 and 3 share?
6.
6. Okay. So what I'm going to do here is multiply the first equation by -3. I'm going to multiply this whole equation by -3. And this -3 distributes to everything. Okay. So this means you'd have -6x plus 3y equal to 0. Okay. Now, I'm going to take the second equation and multiply it by 2. And remember, it goes into every single term. So now you'll have 6x plus 10y equal to 2 times 39. What is that? 68. Okay. So what we have done is manipulated both equations in order to get rid of a variable. And we chose 6 because that is the least common multiple between 2 and 3. Okay. So now, with our system of equations, we will now add these two together. And when I add the equations together, what's going to happen to your 6x's?
They're going to cancel each other out.
They're going to cancel each other out.
Professor, I believe it's 78.
Oh, 78. Okay, good. All right. That makes more sense. Somebody's paying attention. All right. So when we add them together, your 6x's will cancel. You will be left with 13y equal to 78. And now, all we have to do to solve for y is divide by what?
13.
13. And when you divide by 13, we get that y is equal to 6. Okay. There's the first part of our solution. Remember, we're looking for the coordinate point x, y. So now, in order to find that x value, since we know that y is equal to 6, in order to find that x value, you can take this y value and plug it into equation 1 and solve for x, or plug it into equation 2 and solve for x. And it doesn't matter which one you choose because both of them will give you the same answer. So this is all dependent on which equation looks easier to plug into, the first or the second one.
First one.
Let's choose the first one. Find x, and we'll choose the first one. 2x minus y equals 0. Let's go ahead and add that y over, and you'll get 2x equal to y. But now, what is the value of y that we just found?
6.
It is 6 because of that value we found for y. And now, in order to solve for x, all you have to do is divide by 2. And x is equal to what number?
3.
3. X is equal to 3. There we go. And now we state our solution as the coordinate point 3, 6. So that's how we state our solution. Okay. Any questions on that? This was called elimination method. And it is one of the fastest ways to solve a system of equations. So there are actually 4 ways to solve a system, but we're not going to get that crazy in this class. 1 is by graphing, 2 is by substitution method, 3 is by elimination method, and 4 is by matrices, by using a matrix. And the matrix is the fastest way to solve them because you can plug it in a calculator and your calculator will do it for you. And if you guys didn't know, matrices run the world. They do all the advanced computing at a super fast speed. So matrices are involved in anything. Any high advanced math or computer algorithm, there's somebody out there or some computer program using a matrix. So you'll see those later. We'll get into matrices, but we're not going to get crazy with matrices. You're just going to be introduced to them. Okay. And of course, let me give you a visual on what you just found. In case you wanted to check your work on this system, you can graph it using Desmos. Why not? So look, I'm going to type in both of these equations. 2x minus y equal to 0. And then 3x plus 5y equal to 39. And this is what's beautiful about Desmos. It shows exactly where they intersect. And boom, 3, 6. Is that the solution we found? Yeah.
Yes.
Yeah, for sure, right? So Desmos can help you check your answer. Yes, it took it 2 seconds to give us the answer, but of course, we want to do this algebraically. Okay. All right. And then, all right. So let's try another one by elimination method. All right. Number 2. Let me move this guy over here. Let's see. You'll just move over here. Boom. Okay, so you have 3x plus 2y equal to 3, 4x minus 5y equal to negative 19. You guys choose. What variable do you want to get rid of?
Y.
Get rid of y this time. Okay, cool. So now we look at our numbers for y, and you have 2 and 5. What is their least common multiple?
10.
10. So what would I multiply the first equation by?
5.
5. Multiply it by 5. And if we do that, you would get 15x plus 10y equal to 15. Yeah, 15x, 10y, 15. All right. What would I multiply the bottom equation by?
2.
2. Good. And you would have 8x minus 10y equal to negative, oh, no, 19 times 2. Hey, there's my 38, right? There we go. All right. All right. And it's very easy to make a mistake on these with all the algebra and the distributing. So make sure to take your time with these. So that's 8x minus 10y minus 38, and then 15x, 10y, 15. Okay. Now we will add these together, and my 15x plus my 8x gives me 23x. My 10y plus my negative 10y, what's going to happen to your y's?
Cancel out.
Cancel, cancel. And then 15 minus 38, negative 23. Now, if you divide by 23, x is going to be negative 1. Okay. And now we just have to solve for y. Want to use the first equation or the second equation?
Second.
Second. All right. 4x minus 5y equal to negative 19. Let's plug that 1 in. Let's see. Yeah, that negative 1, sorry. So this will be 4 times negative 1 minus 5y equal to negative 19. That becomes negative 4 minus 5y equal to negative 19. Add that 4 over, and you get negative 5y equals negative 15. And then divide by 5 by negative 5, and y is going to be a positive 3. Okay. So there we go. Our solution is negative 1, comma 3. That is the unique point that makes both equations true. That is the solution to both equations. Okay. Everybody go with that one. Okay. Again. All right. 3. 2x minus y equal to 5. Negative 6x plus 3y equal to 7. Who do you want to get rid of, x or y?
X.
Get rid of x. Okay. And once again, look at your numbers. 2 and negative 6. What common multiple do they share?
Negative 12.
That is good, but least common multiple.
Oh,
X.
Just 6, right? So it's good. Yes, we could use 12, but we always want to try to go lower so we don't have to that many big numbers to work with. So between 2 and 6, the least common multiple is 6. So that means we would multiply this equation by 3. And that's going to become, I'll come down here, 6x minus 3y equal to 15. And this one's good because we don't have to manipulate the second one because we already have that least common multiple of 6. So you have negative 6 plus 3y equal to 7. Oh, this one's going to be interesting. What happens to both variables when we add the equations together?
They cancel out.
They all cancel. That cancels, that cancels. And since everything cancels on the left side, that leaves me with 0. And on the right side, 15 plus 7 gives me 22. Now, is 0 equal to 22 a true statement?
No.
No. So this means what?
No solution.
No solution. Good. No solution. So if you end up with a false statement, then we have no solution. Okay. Everybody go with that.
Okay, what did we add to 15 and the 7?
So everything gets added. So all of these terms get added with each other.
Okay.
Good question. All right. And number 4. Oof. All right. 3x plus 1/3 y equal to 3. 1/2 x minus 1/3 y equal to -1. Ooh, who do you want to get rid of here?
X.
Get rid of x, or look at it again. Is this set up already to get rid of y?
Yeah, why already?
Yes.
Yeah.
So we see we have a positive 1/3 and a negative 1/3. So this is already set up for us to eliminate. So it's perfect. We don't have to do much for this one. So this one, we can just add it from the start. And now the only fraction math we have to do is, well, what is 3x plus 1/2 x? So I'll move the x's for now. 3 plus 1/2. What fraction does that give us?
3 and 1/2.
But we have to make it improper.
Oh,
7/2.
Good though. What was that? I heard 7/2.
7/2. Yes.
Good, good. Because remember, 3 times 2 is 6. 2 plus 1 is 7. All right, so 7/2. So down here drops 7/2 x. And my 1/3 y's will cancel. Equal to 3 plus -1, which gives me 2. Okay, now I could divide by 7/2 or multiply both sides by the reciprocal, whatever you want to do. I think it's just easier to multiply by the reciprocal on both sides. So we multiply both sides by 2/7. And on the left side, cancel, 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 cancel. And we get left with x. And on the right side, we get left with 4/7. Nasty fractions. Okay, well, we still have to find y. Oh, we got to plug in 4/7. Which equation do you want to use that? 1 or 2?
2.
Let's use 2. All right, I'm going to say find y. We're going to use equation 2. 1/2 x minus 1/3 y equal to -1. Okay, well, let's plug in that 4/7 for x. 1/2 times 4/7 minus 1/3 y equal to -1. 1/2 times 4/7, that can reduce. That 2 becomes a 1. That 4 becomes a 2. And we get left with 2/7 minus 1/3 y equal to -1. Subtract that 2/7 to the right side, and you have -1/3 y equal to -1 minus 2/7. Okay, the ugliness is almost over. Okay, so -1 minus 2/7. Let's do some fraction math real fast. So -1 minus 2/7. Put this 1/1 and multiply it by 7/7. this would give me -7 over 7 minus 2 sevenths, which would give me -9 sevenths. All right, so now you have -1/3 y equal to -9 sevenths. And now you could divide by -1/3 or multiply both sides by the reciprocal, which the reciprocal of -1/3 is -3. So let's multiply both sides by -3 over 1. And cancel, 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 cancel. We get left with y equal to, and then over here you have 27. So -9 over 7 times -3 over 1. We get positive 27 over 7. So gross. And there it is. Our solution is 4/7 and 27 over 7. Gotta love those fractions, huh? Okay, so that was solving a system of equations using elimination method. Remember, you can use Desmos to check your work if you need to, but you still have to show all the algebra. Okay, everybody good with those? Okay. All right, well, if you can have algebra in the system of equations, then you can use system of equations in word problems. Oh my goodness, right? So let's check out these word problems with the system of equations. Yeah. So an animal shelter has 105 cats and dogs. They have 15 more dogs than cats. How many dogs do they have? And how many cats do they have? Okay. So we're not given the exact number of cats and dogs. It's just saying an animal shelter combined has 105 cats and dogs. So what we're going to do for this is we're actually going to have to create our own system of equations. So our animal shelter has X amount of cats plus Y amount of dogs, and the total of cats and dogs together is 105. But now it says they have 15 more dogs than cats. So another equation we can make is if they have 15 more dogs than cats. So remember that cats is X and dogs is Y. What equation could I write for 15 more dogs than cats? Y equals what?
15. Never mind.
Yeah, you almost had it. 15.
Would it be y equals 15x?
If it's 15x, then this means they have 15,
Oh, why?
15, what is it? 15 times the amount of cats. But we only have 15 more dogs than cats. So 15
Plus.
plus X. There you go. Man, that'd be a lot of dogs, huh?
Yeah.
Okay. So, oh, this is going to be fun. Now, I'm going to introduce you to that method I told you about called substitution. So remember, there are two ways. There is this, well, it means there's four ways, but two ways: substitution and elimination. Well, what we have done is set this up perfectly for substitution. Look at this. Y equals 15x. That means I can take that information for y and plug it into the first equation. So this is how substitution method's going to work. So watch this. We're going to say substitution method. Hopefully I spelled that right. Looks like a lot of T's in there. So we're going to take this equation, x plus y equal to 105, and we are going to plug in 15 plus x for that y value. So you're going to get x plus 15 plus x equal to 105. Well, now this puts the equation all in terms of x, meaning we can solve for x. So if you drop those parentheses, you'd have x plus 15 plus x equal to 105. And then add those x's together. You'd have 2x plus 15 equal to 105. Move that 15 over, and 105 minus 15, I believe, is 90. And you'd get 2x equal to 90. Divide by 2. And how many cats do we have? What's 90 divided by 2?
45.
45 cats. This means how many dogs do we have?
$60.
Good. 60 dogs, right? So y equals 15 plus x. That means y equals 15 plus 45. And we get that we have 60 dogs. There we go. So 45 cats, 60 dogs. We have 15 more dogs than we have cats. All right. Everybody good with that? So this is how we're going to set up all of these types of word problems. So they're giving us what to put, and we just have to translate English into algebra. Okay. So number 6, there were 429 people at a play. Admission was $8 each for adults and $4.50 each for children. The total receipts were $2,641. How many adults and how many children attended? Okay. So this is kind of like the cats and dogs one above, almost. So for this one, adults will be X, children will be Y. And in total, how many people were at the play?
429.
So X plus Y equal to 429. Okay, so this equation represents the amount of people. The next equation is going to represent the total amount of money. How much was it for each adult ticket?
$8.
So we're going to have 8x plus, how much were the children's tickets?
$450.
450y. And how much money did the play make total?
$2,641.
2,641. There you go, guys. We set up a system of equations, and now we have to solve it, unfortunately. So we create it and we have to solve it. So now let's go back to elimination method. Who do you want to get rid of? X or Y?
Why?
Why?
Get rid of Y. Okay. If we want to get rid of Y, what would I multiply the first equation by?
4.50.
4.50, but it's going to have to be what? Positive or negative?
Negative.
Because right now, both of these are positive. So they can't cancel if they're both positive. One has to be negative, one has to be positive. So if we're going to get rid of y, the first equation must get multiplied by negative 450. So we'll say negative 450 times all of that. So this ends up becoming negative 450x minus negative 450y equal to negative, and 429 times 450 is 1930.5. Okay. And then this equation stays the same. I'll put some decimals in here to let it match up. $8x plus 450y equal to 2,641 and 0 cents. Yeah, why not? Put all those decimals in there, those extra digits so they line up. Okay. Now let's add these together. And what is negative $4.50 plus $8?
350.
350. So we will be left with 350x. And what happens to your 450y's?
Cancel.
Cancel.
Cancel. And then equal to whatever that huge amount of money is. Let's see. Negative 1930.5 minus 2641. Negative 700. No, not negative. Should be positive, right? Sorry. Positive 710.5. Now, just divide by $3.50. And how many adults attended?
203.
203. Okay. There we go. 203 adults. Now, how many children came then? If it's y equals, not y equals. If it's x plus y equals
126.
429, good. That's 203 plus y equals 429. Move that 203 over, and I heard 226, right?
Yes.
Cool. There you go. 226 children, 203 adults. All right. Everybody go with that one? Okay. 7. You have a total of $180. You have only $5 bills and $10 bills. And you have 9 more 10s than you have 5s. How many of each bill do you have? Oof. All right. So here we go again. All right. Let's see. We have $5 bills, so that'll be X. We have $10 bills, that'll be Y. And what we know is that our $5 bills and $10 bills equal an amount of $180. So that's our first one. We're going to say 5X plus 10y is equal to $180. Okay. Now, the next part says you have 9 more 10s than you have 5s. So that would be y equals, you have 9 more 10s than you have 5s. What would I write?
9 plus X.
9 plus x. Good. 9 more 10s than you have 5. Okay. And this will be like number 5 again. We're going to do that substitution method. Since we have it as y equals, we're going to plug that into the first equation. Oh, word problems, right? 5x plus 10 times y, which is 9 plus x, equal to 180. Okay, we have plugged 9 plus x in for y. So this went in for y. Okay. Now, distribute this 10. So we'll have 5x plus 90 plus 10x equal to 180. All right, almost there. Now we can add our x's up. And you'll have 15x plus 90 equal to 180. Move that 90 over. And we'll have 15x equals 90. Divide by 15, and how many $5 bills do we have?
6.
6. So 6 $5 bills. So let's just say 6 5s. That means how many $10 bills do we have?
15.
15. 15 10s. All right, cool. Everybody go with that? Okay. Last one for these word problems. All right. A retired couple has $130,000 to invest to obtain annual income. They too invest some in a safe certificate of deposit yielding 0.50% and the rest in riskier AA bonds yielding 1.10% per year. Assume both yield simple interest. How much should they invest in each to realize exactly 1,190 per year? Okay. So let's see. We want to make 1,190 per year at those rates of investments. So our first equation, excuse me, is going to be, so in a safe certificate of deposit yielding 0.50%. So that's going to be our X. And remember, we have to convert it to decimal. We have to go from percent to decimal. So 0.5%, I believe, is 0.005. Oops. 0.005x, right? 1, 2, yep. Plus, and then the next one is the AA bond. That is 1.10% per year. So convert that to decimal, and you should have 0.011y. So 1, 2, and that'd be 1.1. Okay. And with these interest rates, we want to make $1,190 per year. Okay. But we don't know how much money they have. We know how much money they have. We just don't know how much money they have put into investment 1 and investment 2. So our next equation is just X plus Y equal to 130,000. Okay. Now let's solve for X and Y. And this one, we can do elimination method. So who do you want to get rid of? X or Y?
X.
X. So let's get rid of X. So if we get rid of X, what would I multiply this whole equation by?
0.005.
Good, but
Oh,
make sure to
negative.
make it negative. Good. Okay, so if we do that, you would have negative 0.005x minus 0.005y equal to negative, and let's see, 0.005 times 130,000. That would give me negative 650. Okay. First equation would remain the same. 0.005x plus 0.011y equal to 1190. Okay, we're all set. Add these two together. My x's cancel. And then let's see, 0.011 minus 0.005 is going to give me 0.006y. And then 1190 minus 650 gives me 540. Okay. Now just divide by 0.006. And 540 over 0.006 gives me 90,000. So this is 90,000 that they have put into the AA bond. Okay, which means how much have they put into the certificate of deposit?
$40,000. Or yeah,
130 minus 90,000.
40,000.
Is that 40 or no? Am I going crazy?
my calculator says so.
Because it's 90,000. Did you say 40 or 30?
40.
The 40.
40. Okay. 40,000. And that's in the CD. All right. Tell you now, if you do a certificate of deposit, that is the slowest, most safest way to make money. Your bank offers CDs and just put money in there and forget about it. Just make sure to choose the option to keep it rolling over. Because after every year you'll have interest that you've gained, just roll it over. Because I mean, look, these are the rates your bank would offer, maybe even less. 0.5%. Like, come on. You won't make that much, but you will never lose. If the stock market crashes, it does not affect your certificate of deposit. So that's something to think about. But again, it is the slowest, safest way to make money. So look into it if you want. Okay. All right. So that was system of equations. Everybody good with those? All right. Last is matrices. Okay. So easy. We get matrices, the easy version. Okay. So if you're ever determining the size of a matrix, the dimensions of a matrix are always given by rows times columns. So matrices dimensions are always rows times columns. So when you look at matrix A, how many rows do you see?
3.
3,
Three.
right? 1, 2, 3. 3 rows, right? How many columns do you see?
Two.
2. That's it. That's all we're looking for. That's all this wants. Determine the size of each matrix. Okay. So would B be the same dimensions?
Yes.
All right. 3 by 2. All right. What are the dimensions for matrix C?
2 by 3.
How many rows do you see there?
2 rows and 3 columns.
2 by 3, right? And then what would the dimensions for D be?
2 and 1.
2 by 1. Okay, not bad, right? See, matrices are easy for now, or for you guys, forever. Okay. So next is we want to write each system. So here we're given a system of equations, and all we want to do is write it as a matrix. So when you write these as a matrix, every column, here, I'll do this. So when you write a system as a matrix, every column represents a variable. So the first column would always be for x's. The second column would always be for y's. The third column, if you're given the variable of z, would be for z. And the last column would be for your constant, which is just the numbers by themselves. So whenever we're plugging into the matrix, oh, that sounds cool, right? You only put the coefficient. Okay, so let's go ahead and convert this system into a matrix. So I'll show you how to do it. So first you want to get your dimensions down. So we see that you have one column here, one column here, one column here. So this is going to have 3 columns. And since there's 2 equations, it's going to have 2 rows. So our matrix should be a 2 by 3 matrix. So let's set this up. When we convert this system, remember that the first column is for all your x values. So since my first x value is a 5x, I'm going to put 5. And then my second x value is a 1x. So I'm going to put 1. And then we move to the next column for my y's. Negative 4y, negative 2y. I get negative 4, negative 2. And then my last column is for the constants, the numbers by themselves, a number without a variable. And you put 9, negative 3, close the bracket. That's it. Nothing crazy. We're just transferring from system to matrix. And you can also transfer from matrix back to system. Everybody go with that? All right. All right, number 10, same thing. How many rows do you see?
3.
3. How many columns?
4.
4. Okay. So let's start our matrix. So we'll start with all the x values. What do I put in the first column?
3, 1, negative 1.
3, 1, negative 1. What do I put in the second column?
2, 2, 4.
Negative 2, 2, 4. Third column?
Negative 3, 3, 6.
3, 3, 6.
5,
And good. Negative 5, negative 3, negative 1, and that's done. Not bad, right? And then what you would do if you were taking college algebra for STEM majors is you would solve all of this by hand or plug it into the graphing calculator and it would do it for you. But it would solve the system of equation like that. It's insane. So, all right. So that's going from system to matrix. Everybody go with those two. All right. Okay. So now we want to write the matrix as a system of linear equations. So like I said, you can work it backwards. So we're going to go from matrix to system. So let's start with the first row. Since you have 3 columns here, remember that this is X, Y, Z, and constant. So what would I translate the first row into?
3x minus 2 plus 4 equals 6.
Good. 3x minus 2y plus 4z equal to 6. Good. What would the second row be?
9x plus 4, y
Mhm.
plus negative 1z
Uh-huh.
equals 0.
Good. And what would the third row be?
6x. Subtract 8 and 8. Negative 3.
Not bad, right? So there you go. That shows you that if you could go from system to matrix, you can go from matrix back to system. Okay. And now, oh my goodness, guys, last one for the semester. Whew. Use the given matrix to write the solution for the corresponding linear system. Okay. So we want to, of course, go back from matrix to system. So if we're going to convert this, remember that this column's X, that column's Y. And what would I write for the first row?
1x.
1x. Is there a Y value?
0. Nope.
So just X equals,
Negative 7.
there you go. And what would I write for the second row?
Y equals 4.
That's it. We're done. Woo!
Straight up the answer.
That's it. All right, cool. Well, that was systems of equations and matrices. That was like matrices, like super light. If you ever want to see matrices get crazy, just Google it or YouTube it. They're pretty awesome what they do. You can even, if you like playing Sudoku, you can even use a matrix to help you solve your Sudoku puzzle. Okay. Before we head out, again, where's our Canvas page? Let's see. I even have that up somewhere. How did I get here? Where am I? There we go. Okay, you go up there, you go there. Again, I will open the final on Wednesday, and it will be due next Wednesday, the day of our final. Remember, there is no class next week because it's final exam week. So if you have any questions during that time, just email me. What else? The homework for this one isn't due till next Monday, the 6th, that we just went over, equations and matrices. And then one more special treat. I have something called an assessment question. So we're supposed to give these to our students every fall semester, and it's supposed to gauge where their understanding of the course. And what I do is I like to offer it for extra credit, even though they tell me not to. So this is just like the student survey. If you haven't done the student survey yet, remember, do the student survey, take a picture of the message that says complete, and then upload it, and in the comment section say, you want 5 points added to this test, or this test. So same with the assessment question. Work the assessment question as best as you can, submit it, and when you submit it, in the comment section, say you want 5 points added to exam 1, 2, 3, 4, or the final. So add it to any test of your choice. So I am giving away 10 free points. Look at that. The student survey and the assessment question. And the assessment question goes over what we just learned. So if it will load. Hopefully I didn't mess that up. Come on, internet. Oh, there we go. Okay, so it is a system of equations problem. Look at that. So it's asking you to set up the equation and then find out, what did it say? Select which setup you think is correct and explain why, and then explain the errors. Again, just do it the best you can and upload it and tell me where you want those 5 points at. Any questions on that? Everybody good?
Yep.
Okay. So Wednesday night, if you want to come to class, like I said, for the final review, just look over exam 1, exam 2, exam 3, look over your exam reviews. So sorry, exam 1, 2, 3, 4, look over the reviews for exam 1, 2, 3, 4, look over the last set of notes, the matrices and system of equations, and we can cover any of those questions Wednesday night. I'm not making a final review because, again, you can look over all your exams. And let's say you have a question over a problem you missed on the exam, we'll bring that Wednesday night and we can look at it. Other than that, if you're all good, you don't want to come Wednesday night, then it's been a pleasure. Enjoy the rest of your semester, and good luck on finals, and have a good Christmas break. But if I see you Wednesday, I'll see you Wednesday. So that's it, guys.
Professor, I have a